We are live in the first ever SuperGeek X-1 unified Sudoku formula release video and tutorial. I am Duke, proprietor of SuperGeek, CRS research campuses, or CRC, and X-1's a formula that I formulated well over 20 years ago, and it can be utilized in any square, row, or column of any level of Sudoku at any point. And then as you go through you're still going to use the same standard, as I call them, projections, which eliminate other squares across the puzzle. And I also have a few other techniques one called ghost projections and double ghost projections, outside ghost projections, and inside ghost projections, which couple in with the X-1 unified formula. And as I go through it, at any point, what's real exciting is when you get an answer, even if you're using the standard projection techniques, anytime you fill in an answer, it actually betters the chances of the X-1 formula functioning and getting a further answer, and then so on and so on. So the more as you go through the puzzle, as you get more answers that are correct, they can be verified through my formula, or sometimes it can be found through my formula a lot easier as a puzzle progresses. And when it gets near the end, you can apply the formula all over the place and it will verify the answers, but you still have to be careful not to go too fast, especially in the later half of the puzzle. So I'm going to start this one here and just use my regular techniques of projections, standard projections, ghost projections, which are unknowns that are projected. You know where an unknown location is, and then double ghost, where you get two numbers being projected to combine with the X-1 formula. Now the X-1 formula, X stands for the number of unknowns in any column, row, or box. And what you do to apply this formula, you look for a section that has the least amount of unknowns, and then you put them in your head, and you got to find, say there's three of them, three unknowns. Use this, as I go through the puzzle with standard techniques, when I start applying the X-1, I will explain, how I got some notations that I do on the outside, but I don't do this formula will teach you Sudoku, and very easily and fun to utilize. So I'm just going to go through, start it out just as I normally would. I can project this 3 straight up vertical, and there needs to be a 3 in this square, so the only option would be in that particular square, which is verified by a 3 projection. Then further, over here I can see another projection similar. There's a 2 projection down, 2 projection up, and that for this particular square leaves one option of a 2. Then another a standard projection, project 7, which is going to make 7 be here, so that's going to end up in a double projection, 7 and then 7, because it can only go in those 2 sections, or it gets crossed out by this one and this one. So it'll go straight up into that one, straight up into there, that's all eliminated, and then these 2 7s cross project across, so everything up and across, and that leaves 7 being there. Now these are just standard Sudoku projections. As you get going, I will start applying my formula. You can apply the formula anytime you want, but I'm going to apply it once I get rid of the standard projections that I see right away. And there's also ghost, I guess it's repositories in squares, and then they can be utilized as projections, and then also be further utilized to administer the X-1 formula in whatever, depends on where the ghost projections are. That means that they're just there And I'll give you an example right now for this square. If I go 9, 1 straight up, and or 9, 2, 9, 2 across, and 9, 2 up, and 9, 2 across, leaves only 2 squares for the 9, 2. So I don't know where they go. So the notation, I put a line, and then over here I will put 2 and 9. So I know that those two are 2 and 9. And then I got 1, 2, 3, 4, 5 left. And because those are 2 and 9, then the 6 projection I can see going up and up puts a 6 in that square, and that's just standard 6 projections. Further leaves 4 unknowns. I know because I know 2 and 9 are in those two, so the 4 unknowns, I'll put them in my head as I would, normally when I go through the puzzle, I do this all the time. And that would be 1, 3, 1, 3, 5, 8. So I got 1 and 8 cross there. I got 3 across there. So I don't see any good aspects for my x minus 1. I'm just doing it in my head right now to see if I can formulate one. And oh, okay, I found another projection, and this is just going through the puzzle. Once I get into the later stages, you will see where sometimes you can't find any standard either projections or ghost projections, and you will start seeking out to use my formula, and that may get you an answer that'll carry on and affect more standard projections, ghost projections, or exercising the unified x minus 1 formula. So, but anyways, I see a 2 standard down projection, another 2 projection, 2 across, that leaves 1 spot for 2 there. Then we got 2 across, so 2 is going to be in here. And it's also, yeah, I got to find some more. So I'm still doing some more. Let's see if we can, 3, 5, 3, 4, 5. False. Okay, here's another standard projection. 4 down, 4 down, 4 across, so 4 will be there. And then what happens now, 3, just looking to see if I can find one. Anytime I do get an answer 4, that may create another projection or an opportunity for the x minus 1. So I'm running through those through my head until I find the first verified x minus 1 function. And some puzzles it'll come across, you'll see them all the time. Other ones you don't need to use it as much if you're getting the standard projections like I am right now. But once I get stuck on standard projections, or ghost projections as I call them, I will a lot of times switch to back and forth between standard and the Geek unified formula. So 2, 2 and 9, so that leaves 1, 3, 5, 1, 3, 4, 5, 6. Okay. Oh, so I'm gonna actually put there's another notation I'm gonna do. There's three unknowns in that sector of that box, and I know I put them in my head. I can apply the X-1 formula. That would be, it's not going to work, but I'm going to show you. It would be 5, 7, 8. So I put 5, 7, 8. And then I can use that. I got the notation, so I can quickly reference it as a projection. So you can see 5 and 7 coming down, and 5 and 7 going across. Yes, 5, 7, 8. Yes, 1, 2. Okay. Yeah, I think I found another option, because 9 comes down here. 9, oh, actually, it's going to fit in, because I got 9 across, 9 across, 9 down, so 9 will end up there. That puts a 9 on this outer corners, and then with this projection down here for this square, it puts 2 9s on the outer corners, so that becomes an outside ghost projection. So I know that 9's there or there, and 9's there or there, so that'll project all the way across and eliminate all of them with 9's. So it would be 9, 7, 5 would be eliminated from there, and 9, 7, 9, 7, 5. So I'm looking for combinations. Now I got the 5, 7, 8 here. I can apply the X-1 unified formula to the remainders. I know they're going to be ghost spotted. So and that's 5, 7, 8. So I look at there and I put the remainder in my head. That'll be a 3 unknowns. So it'd be 3 minus 1 is 2. Got to cross one of those 3 numbers. And those numbers are, put them in my head. I can actually notate them down too. That would be 1, 2, and 9. And I know 2 and 9 have to be there, so the 1 will have to be down here. And I'm just going through some more. Now, because I did get that last number 9 over here, sometimes, oh, there you go. I'm going to do standard projection, 3 up, 3 across, so that notates a 3 will be there on space projections. And then that'll actually bring a 1 trapped in here, which will do a projection across and go with that 1. So that would be leaving a 1 there. And I'm looking for, and also that 9 and 3 will reduce the vertical column unknowns, which again I can apply X-1. I'll do that right now quickly in my head. That'd be 1, 7, 8. And I do have an, oh, no, it'll be 1, 6, 7, 8. So I got 7's covered by there. 6 is in there. 1, 6. I'm also going to do some more right across. Put them. It's real easy once you practice it. Like I said, if I'll use this row right here, it can work on every row. You don't know till you apply it. So that's 4 unknowns. So that would be 1, 3, 5, 8, and I got 5 and 8, and 3 against there. Now that is 2 and 9. And I get 3 there. Looking 3 all the way up. 3 and 1. 1, 2, 4. Or 1, 3, 4. Okay, I'm gonna try. Sometimes there'll be an easy one. You kind of overlook it, but as you get them going, 2 9, so that would be 1, 1 3, 1 4 6. Yeah, so 5 and 9. 9 and 5. 9 and 4. Now, like I say, when I do these puzzles, sometimes I will start one and then I will stop, because you have to, the flow of the, here I'm going to,
this is the way.
That's my Mandalorian soundboard.
This is the way.
And sometimes I will watch different TV shows in the background or listen. I can't really play any copyrightable music, so I'm kind of left with a soundboard. But when you go through it, applying, like, you got to remember, you can apply the X-1 unified formula on any row. And look at all the rows and all the columns and all the individual squares. And then every time you get an answer through your standard techniques or standard projections, ghost projections, or my unified formula, that further betters the odds of the unified formula working, because the lower amount of unknowns, which is X, results usually in the formula having the greater odds of having a cross-referencing to prove the unified answer through the X-1 formula. So I'm just going through my standard techniques, looking for trends or ghost repositories of numbers that I can utilize. Okay, I think I might be onto something. 6 6. Okay, I got a ghost repository because I got 6 7 down here. So that puts this, and this has to be 6 7. I don't know which one it is. And then this one, I get 2 more ghost repositories. That'd be 6 7. So there's only 2 left. That would have to be 9 and 8. Now I can use them to project across, and if I go the, okay, if I go the 8 projected vertically up to this where there's no 8, and then 8 comes across, project the standard 8 projection, ghost projection, and that results in a precise answer of being 8 in that particular square. Now I can do a further projection, standard projections, and I get an 8 there. And then you don't want to get going too fast, because sometimes the answers will come very fast when you use my, it's a combination of my X-1 unified formula, which incidentally can be applied at any given time, even if you got 1 square left, which you know the answer, you can apply that to the X-1 formula, and it will prove that what the answer is of that 1. So it applies to any amount of unknowns, and it will prove it if it meets the definition of finding X, the number of unknowns, minus 1. That's the amount that you have to find that cross one of these squares in the column, row, or square. And the one that does not, if that amount crosses one, then the one that doesn't cross it, that's in your head, becomes the answer, the unified answer, according to the SuperGeek unified Sudoku formula. Now I only do the hardest. This is fiendish Sudokus. I usually have about 6 books on the go at any given time. But what it does is that using that formula, when you apply it, it makes the game more exciting, because it could possibly work on any. I've had it work on a 6 or 7 unknowns. Yeah, and it's actually in those like weirds, like there's no way you could possibly have gotten that answer, but I did. So I'm going to start going through some. I just got that 8. So what I do is I got the notations up here, 5, 7, 8. I'm going to do a standard projection down, because there's no 8 in the square. Projection from the notation down, so that produces 8 there. And then I can carry on and I can do more projections. That's 9 and 8. And you will get a lot of standard projection answers, because now I can see here, there's only 2 unknowns left in that column, which is 3 and 5. And then I know that is 2 and 9. So this has to be 1. So you can see as you go through, that's with standard projections, you will get it will make it fun, more fun than you really expect, because every time, now that I got that there, I can try the X-1 to that row or this column, and you may get the answer. So let's go now. Let's apply it to that row. Hopefully I got synchronization. This is the 3rd time I've done the video. The first 2, the voice got lost with the synchronization of the video, and so when I was watching it back, it didn't make any sense when I was thinking and pointing with my pen or making notations or explanations. If it's not in sync, you're not going to be able to make heads or tails of what I'm talking about. So now we will apply it to this row, and that'll be 3, 5, 6, and I got 6. And now if I look here, I just on standard permutations of projections, 6 crosses there, 6 crosses there, so 6 has to be there. Now I can project that down with the 6s over here and across, and I will get 6 in that square. You can see as I'm going along, I haven't really had to use my unified formula very often, but I am getting the puzzle completed with the SuperGeek ghost and ghost projection and double ghost projection, and outside and inside ghost projections, coupled in with the unified X-1 formula. So I pretty much think I pretty much know I could probably solve this relatively quickly, but if you go too fast, you will make mistakes. Because even though that I'm at the point I believe it's solved, so I'll just do some standard, I'll make sure and do it slowly. So I'll go 6, here's 6 notations. That brings 6 across, 6 down, 6 down, so 6 will be there. And on the same note, I can do, there's a 7 across. I just notice it now, 7 across, so 7 will become there. I can apply now that there's 2 unknowns, I can apply my X-1 formula just as a showcase on how it would work, because it will work with any amount of unknowns. So that becomes 8 and 9 are the 2 in my head, and 8 crosses this one. So that number of unknowns is 2. So it's 2 minus 1 becomes 1. So you put the 2 unknowns, 8 and 9 in your head, and one of them crosses it, which is 8. So the one that doesn't cross it, that's left over, becomes the answer, which is 9. And then subsequently, I can even, for here, there's the unknown of 8 down there, or one answer. So It's one unknown, so 1 minus 1 is 0. So I need 0 to cross that, and the one that doesn't cross it, which is, if I don't need any to cross it, the one that doesn't cross it is 8, becomes the answer. And that's the last number. You need 1 to 9 in each row and column. And because I have 6, 7, I know is a ghost spotters, and then the only one left is becomes 9. And that was, I can cross that out too as you start solving them, especially when you've got the notations for the ghost repositories. I'll cross one of them out sometimes if I get it. So, and you can, and right now it's kind of fun. You can apply the X-1 all the time. Now here, because I know there's a ghost repository of 6 and 7, so then it becomes the unknowns. There's 4 unknowns, 1, 2, 3, 4, which becomes, okay, 6 and 7, so that would be 1, 3, 5, 8. Or no, 1, 3, 5, 9. So I put that in my head, and I got 5 and 9 have to be in there. And there's a 5 notation coming down, so 5, 5, and 5 becomes there. I can apply X-1 to the remainder of that box. That would be, and it's kind of fun just throwing it out there and putting it in your head. And I'll show you how it'll work in this little square here. So there's 3 unknowns, so it's 3 minus 1. That becomes 2. And the 3 unknowns are 1, 2, and 9. And in the 3 boxes, 1 and 9 cross this one right here. So the one that doesn't cross it of the 3, because there's 3 unknowns, and 2 of them do, 1 and 9, so the one that doesn't is 2. So 2 becomes the answer there. And then just through a standard projection, bring the 9 has to be there, and there's only 1 left in that square, and that becomes the 1. But I still could have applied the X-1 formula just to prove that the 1 and 9 were there, because it will work from 1 unknown to 8 unknowns. And then we got this row here. We can see pretty much we got the puzzle done. But like I said, take your time. So we got 2 unknowns in that row, and that would be 4 and 8. 8 comes down, so 8 would come across, and 4 would be there. That leaves 2 unknowns for this square, which is 1 and 3, and then I can do it vertical. That would be 1. Actually, I can do a standard projection. Just saw it now. 4 up, 4 across, so that puts 4 in that square in this box. Project up, 4 up, 4 up, 4 across. 4 becomes there. There's 2 left, 1 and 3. No, nothing there. Let's do, we got 3 projections, so 3 comes in there. Let me make sure my film is working. Yes, so 3, and then out of this square, I can apply it to the square, your rows, columns, wherever you want it. X-1 will work, and it will prove every single answer that you submit onto the puzzle. Sometimes you will get one, you will put it in there, and if you believe in the formula, it is the correct answer, if it meets all the conditions of the X-1 criteria that I just explained. So we're going to go, and this one's going to be 1, 7, 8. And on standard projections, 8's going to eliminate those 2. It's only going to be there. 1 and 7 are going to be here. However, over here, I do remember from before that 1 going up vertical produces a ghost projection of a 1, and somewhere in there, coupled in with the other one, that's a double a standard projection, ghost projection, right across the puzzle, eliminates that from being 1, so 1 has to be there. 1 left in that square, that would be 7. Further, I can project that 7 across. That's going to produce a vertical ghost projection of 7 down, which is going to cross out. There's only 6 and 7 left, so 7 will have to go there, and then the last one left is 6. 6 vertical projections, standard projection, put 6 in that location for that square. And then don't, like I said, don't go too fast. You can do standard projection up here. There's 3 unknowns. I could apply X-1, but a lot of times when you get to this point, you're just going to use standard projections. 1 straight up, 1 across. It's going to put 1 there. There's 3 left, or 2 left over. That's 3 and 5. 3 is going to scramble over to here on a standard projection, and that leaves 1 left for that box at 5. 5 across is going to standard projection, put a 5 in there. Alternatively, I could have done it because there was only 1 left in that location. You could have applied X-1, or just knowing that there's only 1 left and it is a 5. 1 and 9 are on the, or no, that's 2 and 9 on the outside, so that leaves a 3 in the middle. 2, I got a 2 projection up here, so it's going to put 2 there. It's going to put 9 over here. I still have these ones here, 5, 7, 8. Don't know if I, oh, yes, I got a standard projection, got a 5 there. So 5 and 5, it'll put 5 up here, and then that'll be, and then 7 projects across, that'll put 7 there, 8 there. That eliminates those ones. Coming across, there's only 1 left in each one, so it's going to be, actually, even though I can do a 1 projection up to put a 1 in there, and then the remaining 3 in this particular vertical, or that square, or that vertical column would be 4, 7, 8. And I got 2 8s come across, 7 to cross, and 4 becomes there. Like I said, don't go too fast. 1's going to project across, put a 1 there, 1 project down, 1 here. Because if you go too fast, sometimes you will, because you're putting numbers in your head for the in and out for the unified formula. And if you go too fast, it's very easy to misspot a location, or write into the wrong square, or misread something that you're going to bring as a projection. So be very careful. Put them in your head. Here, there's 3 and 5. And verify 3 and 5. There's only, and then 5 projects, and then 3 is the last remainder in that square. And then down here, you look what's left is 3, and there we go. Puzzle is done, and I'm just going to do 1 for these tutorials each, and I'm going to try to release 1 a day on the SuperGeek CRC YouTube channel. And you will see it. I mean, everyone is different when you use this formula. Sometimes I've used the formula to begin a puzzle, and it worked. Sometimes I will just use standard projections. Sometimes standard projections don't get you anywhere, and you have to use this formula. But you can apply it all over, and then when it comes through, especially the real big ones, like 6 unknowns, and your formula works, and you get the answer, and you're like, is it really the answer? Well, if you believe in the formula, it meets all the conditions, it will be the answer. And like I said, I think we've been recording, not sure how, 30, I can see on the recorder, 33 minutes, I believe. So it is quite I could have done it faster. I'm trying to, record and think and do everything at the same time. But it's still fun. And like I say, when you know this technique, if you can't get past a puzzle, you can leave it. Usually what I do when I finish them, I sign them, just so I know that it is properly completed. If I don't complete, if I make a mistake, or, put a, if it somewhere it doesn't work out, there's no use going back and fixing it. I'll put a C through it, and I won't sign it. And then that way I know when I go through my puzzle book, if I got ones that are partially completed, I can go back to them and continue to apply the formula. And it's fun. And sometimes when you go back to them, one that you think you'll never get by, and you'll go back and do it. And you got to remember, I only do the hardest Sudokus that I can find, because this formula is so good. You'll find when you're doing beginner ones with the formula, you can apply it almost everywhere, solve the puzzle, but it becomes fun. And then you'll like it because you're going to be, all of a sudden you're going to understand Sudoku. The formula actually teaches you Sudoku in your subconscious. You don't even realize it, and you become an expert at Sudoku numbers. And like I said, I happen to have a computer science engineering background, and very good with math and numbers, but this logic of this formula is so easy to use that, especially when you watch it be done, and you realize you don't need that many notations, and just standard projections and ghost projections and X-1 formula applications will solve any Sudoku, as far as I'm aware, in the planet. I have been stumped by some that I've kind of given up on, but I got like numerous books on the go, and I will go back.
I have spoken. This is the way.
And that is it. I can do one more.
I can bring you in warm.
And there's the answer. And like, I do prefer to do Sudokus on paper, just so I can put the notations on the outside where I like and how I do it with the little notches. It doesn't clutter the inside of the puzzle. And you can do the same thing on the online ones where you put them in the corner. I can put ghost inputs for the corner inputs, but it's easier, and it etches in your mind when you write the notations on the paper. So when I put that 2-9 down, or 6-7, or whatever, 5-7-8, so when I'm going through an application of the X-1 unified formula, it will come out of my subconscious because it's been etched in there, and so it can do a projection across, either standard or a ghost and standard projection, or a projection to meet the commands and the requirements of the X-1 formula to solve for an answer, which is very surprising. Like when you use that formula, and I will eventually come across one where it'll be 4, 5, 6 unknowns, and I will use the X-1 formula to get an answer, and you will never be able to figure out how that answer belongs there unless you trust the formula. And that's how you know that the formula is correct, and it's unified because it can be applied to any row, column, or square of any amount of unknowns. And it could even one unknown or no unknowns. It will work and apply in theory, according to how I outlined it. And like I said, I've shown people that are average at Sudoku and showed them this formula, and they'll use that with their standard projection techniques they use in their head, and they will solve these hardest Sudoku. I see one person that had never done a hard Sudoku, and I gave him a book and he solved every one. And this guy is like 75 years old. So you don't have to be a math genius. And it will teach you the logic of Sudoku to your subconscious. And it's very easy to use, as you just saw. Like I said, it's easier to use on the lower amount of unknowns because you got to input those numbers into your head. So sometimes I will scribble down the number of unknowns, especially the long ones. If you're doing 6 or 7, you'll write them down vertically. Then you can visually cross them out. And if you get, like I said, X-1 of them to cross-reference, the one that doesn't cross out the square will be the answer. And it'll just amaze you when the formula works, when you had no other option on your standard techniques of whatever you use. Everyone's techniques are based on same concepts of projections. I just happen to call them, I've always called them ghost projections or standard projections, or double ghost, or outside or inside ghost, and then with my unified X-1 formula, which I actually created back in the early 2000s, but I've never released it until now, and just because I was dared on a Reddit. It's a Reddit Sudoku site, which I will post a link to this video, and that's it. Duke out.
I have spoken.